So we recently made a fundamentally new discovery. So far, people thought that neurons communicate only with other neurons or with muscles. However, what we now found is that neurons can also communicate with cancer cells by using traditional bona fide synapses.
We are interested how the nervous system can interact with cancer in general, especially in brain tumors, but also outside of the brain.
Cancer actually is really driven by neural features. So cancer hijacks very important aspects of our nervous system. And in the end, this makes many cancers grow, invade, disseminate, and resist therapies. And this is crucial, of course, to better understand these cancers. We found out that these tumor cells really show a vivid intercellular communication pattern. So our interest was, what is the code of this communication? So by work over the years, I think we are now near to crack this code of communication. Thomas Kuner, Varun Venkataramani and me, we started collaborating for our 2015 discovery paper of these neural-like cancer cell networks in brain tumors.
We first looked into ultrastructure of tumor microtubes.
We wanted to actually understand how the tumor cells look like.
One day the door opens and Varun enters the office quite excited and showed some electron micrograph to me and said, "Isn't that a synapse?" And I said, "Yeah, sure. I mean, that's a synapse, absolutely." And so that was sort of the first documented neuron to tumor synapse that mankind has seen.
I do remember it, how I was very surprised and was very unexpected. So we were not looking at this phenomenon at all. It shows that we always have to keep an open mind also in science to be open to these kinds of discoveries.
One of the big challenges of studying these tiny synapses is that you need quite sophisticated technology. We have established here a number of also new technologies. For example, what we are using a lot is electron microscopy, and so we devised a new strategy where we can cut thousands of sections and collect them and then do three-dimensional reconstructions with nanometer resolution.
We've been using advanced imaging technologies that allow us to really see how information is transmitted in real time. And also we've been using an investigation called two-photon microscopy to really understand how living tumor cells in the brain behave.
But the research environment in Heidelberg is, I think, quite unique in a sense that our campus is very compact. I can walk to pretty much every laboratory here within 5 minutes. And also we have a very collaborative spirit.
I am caring on a daily basis brain tumors, and after the diagnosis, many questions come to the mind of patients. Now, why me? Can I influence these diseases somehow? Can I even influence these cancers by certain cognitive strategies or thinking? In the past, I often have said, well, maybe, I don't know. Now, I must say, yes, that's very possible.
So our work is a milestone because it is a completely novel mechanism how synapses are hijacked by brain tumors. It really enhances our understanding of brain tumors.
And I think this is a field that is just at the beginning. I'm pretty sure we will find many new types of interactions and we'll also find ways of interfering with these interactions. So that I do think that this is a real game changer.
In Germany, we have now started a clinical trial where we test a specific inhibitor of these neural cancer synapses that we discovered to show whether we can find any meaningful effects in recurrent glioblastoma. And we are really looking very much forward to the results of this trial.